Okay, so what does this mean? When we talk about the limit as x goes to a of f of x equals L, what does that mean? Well, to help us understand it, it would be helpful to draw a curve, just a generic curve, and locate a point here on the x-axis A. Now I'm going to assume that the curve is continuous at A so that there is an f of A and it equals L. Now what I want to do next is say, well, what if I add just a small number to L and take a small number from L? In other words, I'll call that number that I'm adding epsilon. So we notice that if we go up epsilon from L, we have a point on the y-axis, L plus epsilon, and if we take that epsilon away from L, we have a point below L minus epsilon, and we get what I'll call an epsilon neighborhood. Now the L plus epsilon corresponds to x2, just some x on the x-axis, and L minus epsilon corresponds to x1, just some x on the x-axis. Now let's consider the distance from x2 to A and from x1 to A. And let's take the minimum of those two distances. Whatever the smaller of those two distances is, we'll call that epsilon. We'll call that delta. So that we create a delta neighborhood. So here you see we have a delta neighborhood. And here's the thing. If I choose any x value in that delta neighborhood, in other words, any x value in this little yellow highlighted part, let's suppose I choose this x value. Notice that it's going to correspond to a function value within my epsilon neighborhood. So if I pick an x in the delta neighborhood, I'm guaranteed that it will correspond to an f of x in the epsilon neighborhood. In other words, if this happens, if x minus a, if I choose an x sufficiently close to a so that this distance is less than delta, then that implies that the function value will be within the epsilon neighborhood. And when we talk about a limit, the limit as x goes to a of f of x equals L, this is what we mean.